All right, in this video, we're going to take a look at another question again, where we're going to take a transformation and we're going to take it, a region in the UV plane, and we're going to modify it and change it into a region in the XY plane. All right, so here's my new transformation this time. This takes in a U and a V, and it spits out for X a U cosine V, and for Y, it spits out a U sine V. So I want to find the image of this rectangle in the UV plane. Okay, so again, I'm going to go ahead and just immediately try to figure out what this picture looks like, and then I can go ahead and make some really quick simplifications to this. Let's see. I'm going to go ahead and start by drawing out my region of R here. This is again in the UV plane. So it says here that R is a rectangle, and it has all points UV such that U goes from 0 to 1, and V goes from 0 to 2 pi. Picture not drawn to scale. All right, so if I was to go like this, this is my rectangle, this is my region of R. It's in the UV plane. Okay, and I want to go ahead and take that region and transform it with T into some region that exists out in the XY plane. Now, if I take a look at this transformation right away, I could use the exact same ideas that we did in the last example. I could imagine taking each one of the sides of my square, or sorry, in this case, my rectangle, and slowly transforming it over. However, in this case, it would be really, really easy to notice that there's something really powerful happening here. With the transformation that we've been given, if we know that X is equal to U cosine V, and Y is equal to U sine V, then this is actually a polar transformation, right? I mean, I think I could see that. Notice that what I have is I'm going to have my V's go from 0 to 2 pi, and my U goes from 0 to 1. So if I recognize this as a polar transformation, I can say here, X is always equal to U times the cosine of V, and Y is always equal to U times the sine of V. This is, a polar transformation. Notice V here represents my angle, and R here is represented by this value of U, the radius. So what I can actually see is that this is going to transform perfectly into a circle of radius 1. Now, again, if maybe you're having a little bit of difficulty seeing that, that's totally fine. I can go ahead and again, use the techniques from the last example to go ahead and actually try to convert this slowly, one side at a time. But oftentimes, if again, I recognize these nice kind of circle descriptions that we've seen even as far back as chapter 2, then these are really great to go ahead and attempt to capitalize on. All right, in the next video, what we'll do is we'll take a look at how we actually start to fully conduct one of these transformations, but first we have to fully try and define something that we call the Jacobian.